Hello, so this is video 2 on expanding triple brackets, and I wanted to have a look at some more complicated GCSE kind of questions. I've got another question generator here, which I'll come back to later. I'll go through how to use that. But to start with, this, like I said, this video 2, in order to do these more tricky exam questions, you need to be comfortable with a number of topics. So multiplying algebraic terms, expanding triple brackets, and then for the really, really tricky ones, you need to be able to solve tricky simultaneous equations and quadratic equations as well. A lot of these really high-grade topics will bring in other areas of maths, and this is definitely one of those. So I've got 3 examples. I'm going to do the first 2 in one video, and then the third one I'm going to do in a separate video. So I've just pinched a couple of these questions from that spreadsheet that I showed you at the start of the video. So if I zoom in a bit, you're going to need a lot of space for these questions. There's a lot of working out to go with them. So we're told in the question, it says, given that x minus 1, x minus 4, x plus a equals x cubed plus 3x squared minus 36x plus 32, we need to find the missing value. So this is the type of question where you're going to work backwards to find that value of a. You are going to need to expand the first couple of brackets as you would normally. So just like we did in the last video, I'm going to expand x minus 1 and x minus 4, and if I did that, I would get x squared minus 5x and plus 4. Remember your rules for multiplying positives and negatives together. So that's what I would get if I expanded the first bracket. Now you're just going to expand the third bracket. So in here, I'm going to write x plus a, this bracket here. So I'm just going to go through x cubed minus 5x squared plus 4x plus ax squared minus 5ax and then plus 4a. So if I write that out, I'll give myself some room. I'm going to write it out over here. In full, x cubed minus 5x squared. I suggest putting the x squared terms together. So plus ax squared. Now we're going to deal with the x's. Plus 4x minus 5ax and then plus 4a. I've just realised you can't see that. Let's try and move that down. There we go. Okay, now this looks complicated, but actually I want you to look through the terms and see if we can see anything that just has an a in it without an x, because that's going to make life a lot easier. So if I looked at the x squared terms, that's got a negative 5 and an a, and the x's have a positive 4 and then a minus 5a. This bit here is the only thing, this bit here at the end, positive 4a, is the only thing that doesn't have an x in it. Now, if I look at this positive 4a, that has to represent that plus 32 at the end. So I know that 4a is equal to 32. And then if I just divide both sides of that equation by 4, I'm going to get a equals 8. You've now finished the question, but you can always just double check it. If I just look at the x squared terms, you could essentially factorize just that bit. Negative 5 plus a, and then normally we'd put the x squared there, but what you can actually do is put it at the end. So like I said, this is the final answer, but it's always worth just going back in and checking as well. So I know that this negative 5 plus a bit has to equal that positive 3, because that comes before the x squared. When I tidied this up, I would get plus 3. We're told that in the question. So if negative 5 plus a equals 3, then I'm just, to solve this equation, I'd add 5 to both sides. So I would get a equals 8, and that match up. You could do the same with the x's as well. I won't do in this video. Let's see if I can scroll down a bit. I keep doing that so you can see it. Okay, second example. Zoom in again. Okay, so this is slightly more tricky because in this question we're told we've got 3 brackets. When I expand those 3 brackets, this is the answer. This is the answer I get. And I'm asked to find out what the values of a and b are. So, just as before, I'm going to expand the first 2 brackets. So I'm going to do that down here. X plus a, I'll tell you what, let's do this color coded so you can see what I'm doing. And x minus 3. So I'm just going to put in here, this is going to be x squared plus ax minus 3x and minus 3a. So if I tidy that up a bit, x squared plus ax minus 3x minus 3a, and then I'm going to multiply that by the third and final bracket, which was x plus b. So I'm going to put that down the side, do my grid, and then in here, x cubed plus ax squared minus 3x squared minus 3ax plus bx squared plus abx minus 3bx and minus 3ab. Okay, this is already looking a little bit more complicated. Let's do it up here. Hopefully you can see it. So I'm just going to write that out in full again. I would suggest, like I did in the last video, cross them out as you go. I'm going to put the x squared terms together to start with. Anything with an x squared in it. Then I'm going to do the same with the x's plus abx, doesn't matter what order you put them in, minus 3ax minus 3bx minus 3ab. Okay, now what I suggest you do is you factorize each part. So there's an x cubed there. Now, with all the x squared terms, I've got this one, and this one. I'm just going to factorize that bit. And rather than putting x squared at before the bracket, I'm going to put it at the end of the bracket. So I know this bit is going to be x squared. And then I'm just going through and saying, okay, to get ax squared, what would I need to multiply x squared by? And that would just be a. To get negative 3x squared, I would need to multiply x squared by negative 3. And then to get positive bx squared, I would need to multiply x squared by positive b. I'm now going to do exactly the same with the x terms. Again, I'm going to stick the x at the end. AB times x would give me ABX. Negative 3a times x would give me negative 3ax. And then negative 3b. And then finally, this bit here, negative 3ab. Now, if I zoomed right out, I know that this bit has to equal the negative 144. So I know, let's write that down here, negative 3ab has to equal negative 144. I also know that this bit here, ab minus 3a minus 3b, has to equal the coefficient, the number in front of the x, which in this case is 90. And then finally down here, I know that a minus 3 plus b has to equal the coefficient of x squared, which in this case was minus 17. Didn't underline that, plus 90. Okay. Now, you've got two unknowns here, a and b, but they're the same in each of these three equations that we've just come up with. The easiest one to work with to start with is this negative 3ab, this one here, negative 3ab equals negative 144. So if I just did negative 144 divided by negative 3, divide that by negative 3, divide that side by negative 3 as well, I know that AB be equal to 48. So I know that whatever my values of A and B are, when I multiply them together, I get 48. The other one that's slightly easier to work with here is this one here. This is the same as A plus B minus 3 equals negative 17. So if I added 3 to both sides, I'm going to get negative 14. Now, I will go through how to solve this using quadratics in the next video on question 3. However, for the time being, you know that A here, add together to give you negative 14, and you know that A and B over here multiply together to give you 48. So if you want, you could list the factors of 48. You could have 1 and 48. You could have 2 and 24. You could have 3 and 16. You could have 4 and 12. Or you could have 6 and 8. However, remember that when I multiply two negatives together, I also get a positive. So each of these could be negative, and each of these could be negative. So out of all of your factors, pairs of factors of 48, you are now looking for two of them that multiply together, add together to give you negative 14. So you can see here that it's got to be negative 6 and negative 8. So back in terms of the original question, all the way up here, the two values we're going to use are negative 6 and negative 8. Now, it doesn't actually matter which one here is which. I'm going to say A equals negative 6 and B equals negative 8. You could put A equals negative 8 and B equals negative 6. But we've now found the two values of A and B. And you could always check that by writing out the question again, but instead of using A, you could use negative 6. And instead of using B, you could use negative 8. And you could expand those three to see if you get that answer. Okay, that's the end of that bit. I will do one final video with this really, really tricky question. So yeah, if you found that okay, you can try a few of your own questions here. Just as before, lots of different questions. You can also, if you don't want to start involving negative numbers, you can just try positive brackets only and get your answers, harder your answers as well. Hopefully that's useful, and if you did find it useful, you can have a look at how to do the last video on expanding triple brackets. Thanks for watching. Bye bye.